there are many turns, there are many loops over here, so then just multiply by n if there are many turns. That's it. Very good, very good. Okay, so we'll complete this formula revision and then we'll go to the problem solving. Yep, don't worry. Yep, we are going to go to the formula revision. Then, just like you had Gauss's law, you have Ampere's loop law. You should just at least remember the statement of it. So if you have currents I1, I2, I3 like this, and let's say you go across a path which encloses some currents, you travel some distance dl, 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 dl and come back to the same point. At every point there will be some magnetic field. You find what is B vector dot dl. Go to the next, find B dot dl. Keep adding it, that means sum it up. Because you are coming back to the same point, cyclic integral. This comes out to be mu naught into enclosed current. Now whenever you calculate enclosed current, it's those current which pierces through this particular loop that you have taken. In this case it is I1 and I2. But be careful, one is positive, one is negative. So they will not add, you will have to subtract them if the directions are opposite. Is that clear? Okay, is that clear? But remember again the same thing. This field is because of all the three, 1, 2 and 3. All the three cause this field. This is because of everything. But here this enclosed is only because of 1 and 2 only. That's it. Perfecto. Keep this in mind. Now, the next thing that you need to remember is field due to straight wires. So, field due to straight wire at any point will be mu naught I by 2r. This is the formula. But I hope you have seen that question which I had marked yesterday, an important study. If you are inside that wire also there is field. Yes, the wire itself has some radius and inside the wire as well there is magnetic field, and depending on how far you are from the center, the field changes like this. Mu naught, same thing, I by 2. Instead of small r, you have capital R square and small r goes on the top. So that's the change when you are inside. So this is for inside and this is for outside the wire. Keep this in mind. Very, very important formula. Next thing, the Ampere से करने की ज़रूरत है. So MD square, if you can solve the question with Biot-Savart's law, so you don't need amperes. If you can solve it easily by amperes, then you don't need Biot-Savart's. They both are interchangeable. You can use it one instead of the other as per your convenience. Next is solenoid. Solenoid ka field. What is the field inside a solenoid? If it is a long solenoid, then the field is mu naught Ni. Remember what is this N over here? This N over here is turns per unit length. Small n is turns per unit length. And if you have a toroid, it is essentially a solenoid. Then also you can find out the magnetic field inside that toroid, and that will be exactly the same. It is mu naught Ni. This N is total turns by total circumference, which is 2 pi r. So if you are wondering what r is the radius of the toroid. Okay, so keep this in mind. So remember one more thing, that the field outside the solenoid or the field outside the toroid is not there. Okay, it's negligible, it's hardly anything, hardly any field lines leak outside, so it is negligible or it is not to be accounted for outside the toroid or outside the solenoid. Fair enough. Next thing that you need to remember is the force between the wires. So if you have two wires which carry current, the force, this is I1, this is I2, then there will be some force between them. Okay, now if they are in the same direction, they will not repel, in fact they will be attractive, so they will attract each other. So that force is given by, what is the force value? Yeah, so it is given by mu naught I1 I2 into the length of the wire divided by 2 pi into d. D is the distance between them. Remember, same directions. If they are same directions, then they will not repel, they will attract. And if they are in opposite directions, then they will repel. It's exactly opposite of electrostatics. That's what I want you to keep in mind. Fair enough. Okay, very good. Now, also remember, a loop of wire which carries some current, it also produces a dipole moment. This is very much similar to a bar magnet with north and south pole, which has a dipole moment like this, just like electric dipole moment. And this M is given by number of turns into current into area. Number of turns into current into area. And if you place this dipole in external field, then it will experience a torque which is given by M cross B. Very, very similar to P cross E. Dipole moment cross electric field gives torque. Same thing in magnetism. Even energy formula is same. It is minus M vector dot B vector. So this dot is nothing but cos. This cross is nothing but sine. Keep this in mind. So the energy is minus M dot B. And remember, the reference energy is 0 when theta is 90. Because cos 90 is 0. So you always measure energy when angle made by that magnetic moment is 90 degrees with respect to the field. Keep this in mind. Okay, these are all very, very important formulas which you should know. Last thing before we actually start doing some problems, is nothing but if you take a charge and if you move it in a circle, this is equivalent to a loop. Okay, so this is the path. This is the path taken by this. It is moving with some angular speed. It is equivalent to a loop which carries current. That's it. And this current can be calculated easily. It is charged by the time period. Time period will be 2 pi by omega. As simple as that. And because it is equivalent to a loop carrying current, hence it will also have some magnetic moment. And there is a very easy formula to remember this. Magnetic moment by angular momentum is charged by 2 times of mass. This is magnetic dipole moment. This is magnetic dipole moment. This is angular momentum. What is this? This is angular momentum. Keep these formulas in mind. It will help you if there is a charged particle which is rotating. Okay, very good. Chalo. Then what else do you have? Okay, so this is one thing. Then yes, you have galvanometer. Let's talk about galvanometer. So in a galvanometer, okay, this is, let's say, 0, there is some deflection and there are magnets. You have the north pole, you have the south pole, you have that coil. The coil will get affected because of the magnetic field, and the coil has some current which is flowing in it. The coil has some current which is flowing in it. It deflects based on the current. There is a spring which is attached, if you remember, which prevents its rotation completely. So when you remove the current, the spring action pulls it back to 0. The needle deflects depending on how much current you pass. So you should know about the deflection theta. Remember, I have told you about basketball. Basketball means NBA. And there is a captain of basketball team. So captain. This is multiplied by current. So theta, deflection, is NBA by current. Constant of torsion into I. What is this C? This is nothing but your torsional constant. Keep this in mind. Torsional constant. Some books have the symbol as K. Yeah, some books will use the symbol as K. That is also okay, guys. Yeah, that is fine. That is no problem. Okay, let's do some questions based on this then. Chalo, let's start. Perfect. So let's do some questions. Will energy and momentum be conserved in uniform circular motion? Yes. In general circular motion, maybe, may not be, Ayushi. Okay. Yes, Vedika, I do teach 11th also. My nurture series are there on this channel. There is a loop of magnetic moment M. Its orientation is given. Okay, let me just refresh this 1 second. Yep. Okay, so The orientation is changed by 30 degrees about an axis perpendicular to the plane. So what is the work done in this case? B, C. Interesting. B or C. Amir, I did conversion of galvanometer into ammeter and voltmeter in current electricity. So just rewind the session back. I have just done it. Okay, I've done it previously, just half an hour or 1 hour back. Okay, now see, this is a circular loop which will have some magnetic moment to rotate the loop by 30 degrees about the axis. This itself is the axis. Maybe there is a magnetic field like that. Please remember, it's given in the question, it is rotated about that axis. That means you have rotated it like that. So when you rotate it like that, this angle is basically constant. So u, which was minus mb cos theta, this theta is constant. So u is constant. So delta u is 0. So work is 0. So the answer is D. Yeah, some of you now got it. Very good, Rishabh. It is not mb or root 3 by 2 or by 2. Be careful. It has been rotated like this about the axis. You will lose marks. It has not been turned this way. Okay, moving to the next question. When a charge of 1 coulomb which moves with this much speed, normal to the field, experiences 100 Newton force, then what is the magnitude of the magnetic field? Okay, so Tarun, it was rotated about the axis. Magnetic moment did not change with field. So theta did not change. How will U change? Potential energy. It will not change. So that's it. Think carefully. It has been rotated about the axis in the previous question. What is the magnitude of the field? A very easy question. Use the formula for Lorentz force. So F is QVB, and it is given that it is moving normal. Normal means theta is 90 degrees. Okay. So force is 100, charge is 1, velocity is 10 to the power 6, B is 10 to the power minus 4, correct? Which is Tesla, which is 1 Gauss. So the correct answer is 1 Gauss, option A. No, it is not B. It is not B, it is 1 Gauss. Be careful. Yeah, many of you made a mistake there. So be careful. So that conversion is important. 1 Tesla is 10 to the power 4 Gauss. 10 to the power minus 4 Tesla will be 1 Gauss. Gauss is a smaller unit. Okay. Chalo, let's get moving to the next one. There is a coil of radius 10 having 100 turns, carries this much current. The field at the center of the coil is how much? What's the field at the center of the coil? Let's apply the formulas and see if we can get this. So, current is given, turns are also given. What is the field at the center? We know which formula to use. B is mu naught I by 2R. Chalo, use this fatafat. How much hand formulas are there, Gunesh? The only one right hand formula. That's it. There is nothing else that you will need. Yeah, that's all you will need. Okay, cool. Chalo, let's see quickly. Find this out. What is the meaning of induced? Hanishma, I will come to it when we talk about EMI. So just hold on. We are going to EMI in a bit. Figure this out. So mu naught is what? 4 pi into 10 to the power minus 7 current. What is the current? 3.2 into radius. What is radius? 10 centimeter, which is 0.1 meter. Okay, this will go like this. So 2 into 3.2, 6.4 pi into 10 to the power minus 6, I guess. Just check this out. Yep. Anything else? Oh, but we have also 100 turns. So into 100. So when I do it into 100, this minus 6 will become minus 4. So 6 3s are 18. So it will be slightly more than 18. Just check this out. Slightly more than 18. So that will go to 20. So 20 into 10 to the power minus 4. So 2 into 10 to the power minus 3. Around that. Just check this out. Option A. Perfect. Perfect. Don't skip this chapter. This chapter is easy. Like you can see, directly formula based questions are there. Direct. Okay. Moving to the next question coming up on your screen. Infinitely long wire, loop and wire. What is the field at the center? That's the question. Let's try and solve this. So first of all, due to this wire, use your right hand put your right hand thumb like this, the fingers curl this way, so the field is this way. So basically, if you think about it, at point O, the field is coming towards you. How much is that value? Mu naught I by 2 distance from the wire. Think of this like a long wire. So field due to a wire, how do you calculate? Mu naught I by 2 distance, which is, sorry, 2 pi r. 2 pi r, that's it. That's the formula. But this loop, it will also produce a field. The current is going like this. So the field is going inside. So there will be a cross. So the field due to that will be just mu naught I by 2r. This is due to the loop. Remember, for a circular loop, there is no pi. For a wire, there is a pi. And you can see one is outside, one is inside. So it should cancel. So I think minus sign should be there because they are opposite to each other. So option C will be correct. Yep. Understood? Got it? So you can see mu naught I by 2 pi is common, and that pi, after taking LCM, you get pi minus 1. Perfecto. Got it? Very good. Very good. Moving on to the next one. Solve this next question. A solenoid of 1.5 meter length and 4 centimeter diameter has this much turns per centimeter. Current is this much. What is the field inside it? So the question is on solenoid. We have the solenoid. Question is, what is the field inside the solenoid? Come on, let's do this. B will be mu naught Ni. Mu naught is 4 pi into 10 to the power minus 7. Turns per unit length, 10 turns per centimeter. 1 centimeter is 10 to the power minus 2 meters. Into what is the current? The current is 5. What is the use of this? No use, just ignore it. So let's see, 4 5s are 20. So 20 pi into 10 to the power minus 7 into, this will become 10 to the power 3. So this will become 2 pi into 10 to the power 4, and this will become minus 3. Just check this out. 2 pi into 10 to the power minus 3, which is option A. Are you getting option A? Very good, make it unique. No issue, it is not C. Be careful. Yeah, it is option A, bacha log. Be careful with the units. The second option said Gauss. Gauss is different. Yeah, be careful. Chalo, let's move to the next question. A galvanometer is there, gives full scale deflection for this current. To use it as an ammeter of 10 amperes range, what should be the shunt resistance? That's the question. I told you sometime back, whenever you see ammeter question, think of it like resistor problems. Don't get confused and don't try to recollect the formulas of ammeter. So this is your galvanometer of 100 ohm resistance. Because you are using it as an ammeter, so you need a shunt resistance like this. Now the galvanometer has a full scale deflection for 10 milliamperes. That means the maximum current which can go through the galvanometer is 10 milliamperes. But when you pass 10 amperes of current from outside, so when you pass 10 amperes current from outside, then it gets divided. 10 milliamperes goes here, the rest of it will go over here. So this will be 10 minus 10, 10 to the power minus 3. Guys, this is a very, very small number. So I can approximately say most of the current, 10 amperes, goes from the other side. Correct? And now we know these two resistors are in parallel. So resistors in parallel, voltage is same. So IR is same. So just do that. Current into resistance. 10 into resistance is current into resistance, which is 10 into 10 to the power minus 3 into 100. This 0 goes. So RS will be 10 to the power minus 1, which is 0.1 ohm. Where is 0.1 ohm? Option B. See if you guys got it. Yep. So what did I tell you? Always treat ammeters and voltmeters like series parallel resistors. Don't remember the random formulas. 1 Gauss is also unit of field MD square, but 1 Gauss is 10 to the power minus 4 Tesla. It's a unit, just like Newton, erg, joule, dyne, centimeter, meter. It's a unit. That's it. Next question. There is a current which is flowing in a wire. Force this much acts in the field. The angle between the field and the current is. Okay, let's see. Hanishma, Tangdu, you can do one thing. You can just message me on Instagram. I'll let you know what to do. Okay, just message me on Instagram. Fair enough. So we have a wire which carries current. Okay, and it is placed in some field, and the field makes an angle of basically, I don't know how much, but there is a force acting. So I know which formula to use. ILB sine theta, IL cross B. What is the force? The force is 15. What is the current? The current is, where is the current? 10. Okay. What is the length? The length is 1.5. What is the field? Field is 2. Sine theta, I don't know. 1.5 into 10 is 15. This is also 15 into 2 into sine theta. So 15 goes. So sine theta, take that 2 below, it will become 1 by 2. Whose sine theta is half? Obviously theta is 30 degrees. That's it. Done. This is how you apply formulas. Very good. You guys are getting it. These kind of questions are going to come in physics exam, and you are going to be like, sir, we know this already. We have attended your classes. This is so simple. You should get full marks for sure. An electron beam which travels with this much speed perpendicular to the field of this much intensity, the radius of the path of the electron is how much? What is the radius of the path? Come on, let's do this question. So the radius is mv by qb. So whenever you take a particle and throw it perpendicular, it goes in a circle, uniform circular motion. The field is like this. So this is the radius. So just substitute the values, you should get the answer. Okay, what and all do we know? Mass. Mass is 9 into 10 to the power minus 31. What is the velocity? Velocity is 1.6 into 10 to the power minus 7. What is the charge? It's an electron. So 1.6 into 10 to the power minus 19. B is 0.1. You can see certain things get cancelled like 1.6. So it should be 9 into 10 to the power something. Okay. So 9 is already there. So just need to figure out the power. So let's see if we can do this quickly. 10 to the power minus 31 minus 7. This will go on the top. It will become plus 1. And this will become plus 19. Chalo, see how much is this power? 10 to the power 19 plus 1, 20. 20 minus 7. Come on guys, do this. How much is it? C for sure? Pakka? Very good. Very good. Yeah, the velocity. Ooh, I did a mistake. Yeah, my bad. Thank you for pointing this out. This was plus. Yes, this was plus. So sorry. Okay, so 19 plus 1, 20. 20 plus 7, 27. 27, and this is minus 31. So this should be minus 4. Check this out. Yep, option C should be correct. Done. Let's move ahead. Let's go to magnetism. Wow. Yes, it is, Aditya. I just made the change as plus 7. Yep, I made it. Okay. Magnetism and matter. There are only 2-3 things over here, and then we'll go to some questions. Okay. So what are the questions and what are the formulas? So let's start with the formulas. So first of all, I would like to tell you about the Gauss's law in magnetism. So Gauss in magnetism. See, magnetic field lines are always loops. So this is a magnetic field line, right? It's always loops. It always completes its path. It never starts or ends. So if you calculate the flux through a surface, if you calculate the flux through a closed surface, then the answer for that will be always 0, because whatever flux is going in will always be the flux which is going out. This is called as the Gauss's law of magnetism, because the net flux through any closed surface, no matter how you take it, is always 0, because the field lines are circular. So whatever comes in should go out. Keep this in mind. That's the first thing that is there in the chapter. Now, is that okay, guys? Fair enough? Very good. Now, the most important thing where people get confused is over here, the dip angle and all of that. So listen to me carefully. See, you have a bar magnet or a needle. Let's say this is the north side, this is the south side. It will point, the magnetic moment will always point in the direction of the external field. Even if you try to tilt it, it will try to come back because of the torque, M cross B torque. Now, this B is basically the Earth's magnetic field. The Earth's magnetic field. The Earth has two components of field at any place. So if you are here, okay, then the Earth's magnetic field has two components. What are the two components? Because the Earth's magnetic field might be at an angle at any given place, there is one component which is called horizontal, the other component which is called vertical. This is basically your dip angle, delta, theta, whatever you want to use. This is called as your dip angle. Basically, it just talks about, what is this? Tan of delta will be vertical, which is BV by BH. Also, BV square plus BH square is B square. Standard. Yeah, standard vectors. Now, understand this B is in a plane called as the magnetic meridian. This plane is called as magnetic meridian. In fact, when you see from the top, this magnetic meridian is like this. So if that person is standing here, this is basically your magnetic meridian. The same thing over here. Okay, from the top it's like this. But if you continue your journey along the field, okay, if you continue, what you will get, you should get the pole of the Earth, right? If you continue going in the direction where the compass needle is pointing, in the direction of the plane, you should get to the pole of the Earth. But you don't get the pole of the Earth. What pole do you get? You get the magnetic pole. Magnetic pole. The reason for this is, if you think about the Earth, this is the axis. The magnetic poles are somewhere else. The poles are not where the axis meets the Earth. It is somewhere else. So you will go to the magnetic pole because that's where the magnetic properties are. The Earth's actual geographic pole is somewhere else. So for that you need to go in a slightly different direction. It's not much different, but yes, it is there. So try and understand this. If you actually want to reach the Earth's geographical pole, then you might have to travel in some different direction. Maybe like this. So if you continue your journey like that, maybe then you will get the pole which is called as the actual geographical pole of the Earth. Do you understand now the difference? And yeah, so the pole of the compass always points towards the magnetic pole, not the geographic pole. It points you towards magnetic pole. Magnetic pole is slightly to the north of Canada and somewhere in Antarctica. That's what it is. So this difference in the angle, this is called as your declination angle. What is it called? It is called as the declination angle. Keep this in mind. So I hope now you are clear what is the dip angle and what is the declination angle. Is that okay? Everyone, shall we go ahead? Okay, cool. Let's do this. There are two different places. The angles of the dip are respectively 30 and 45. And these two places, the ratio of horizontal component of Earth's field is how much? Okay, let's start with a diagram. Okay, let's do this. This is B, this is BH, this is BV, and this is your dip angle, theta, delta, whatever you want to call it. Okay. Inclination angle is the angle which it makes with the horizontal. It's basically in a way dip angle itself. Okay, the angle which it makes with the plane, with the horizontal plane. That's it. Okay, so that's inclination. Dip angle is almost the same. The only difference is that in inclination can be in any given plane. You can have it in magnetic plane also, this plane also, or some other plane also. Dip angle is generally in that magnetic plane only. Okay, so what do you need to do? See, B is same. At both the places, Earth's magnetic field is same. The question is the ratio of horizontal. Acha, BH is B cos theta. So BH1 by BH2 will be cos theta 1 by cos theta 2, because B, like I said, is same. So it gets cancelled. So cos of 30 by cos of 45, cos 30 root 3 by 2, cos 45 1 by root 2. So this will become root 3 by root 2. Is it there somewhere? Yes, it is. Perfect. AMD, the Telegram link is there in the description box below. And yes, if you have a doubt in capacitance, just leave it in the comment section. I'll respond to it. Okay, Kirti Vasan. Moving on. BH is given, BV is given. What is the Earth's total field at that place? What is the total field of the Earth's magnetic field at that particular place? Come on, my warriors. Chalo. Let's see. BH is given, BV is given. We all know that they form a triangle. This is BH, this is BV, this is B. B is root of BH square plus BV square. You can see the power of 10 is the same. So it is essentially 4 square plus 2 square. The 10's power, you can take it outside. 4 square and 2 square together will give you root of 20 into 10 to the power minus 5. Root 20 is 2 root 5. Very good. That's it. Very good, Sanjeet. Excellent. Moving ahead to the next question. Just simple vector addition and Pythagoras. Now this is going to be a slightly tricky question. Magnet is suspended at an angle of 30 to the magnetic meridian. It makes an angle of 45 with the horizontal. Then the actual dip is. This is a very interesting question. So Pranav, if you want to join the JA program, there is a link just in the description box below. Just go to Crash Course G 2022. Just click on that link. Everything is there. You can just join it. Everything is applied already. The batch has everything, all the details, you'll get it over there. Okay. So even if you have any doubts, you can contact me on my Instagram handle Shreyas_Vedantu. So what do you do now? Here, what I will say is this is your magnetic meridian. Then this is your geographical plane. That means here if you go to the geographical pole, and if you go in this direction, you go to the magnetic pole. There is an angle between them. The magnet is suspended at an angle of 30 degrees to the magnetic meridian, and it makes 45 degrees with the horizontal. Very interesting. So the needle is making 45 degrees with the horizontal. That means, okay, it's like this. This is 45 degrees. Good. And 45 degrees with the horizontal. Fair enough. Now, the magnet is suspended 30 degrees to magnetic meridian. So you are taking some random plane now. You are taking some random plane, not even geographical plane. Okay, let's say this is some random plane. And this is basically 30 degrees. The question is, what is the true dip angle? What is the true dip angle? That's what has been asked. So the best way to visualize is like this. Okay, forget about all this. I'll start from beginning, so that, because I just made a small mistake when I drew the diagram. I'll just correct it over here. See this. The magnet is not suspended in the magnetic meridian. It is suspended in some other plane. That's the catch. So this is some random plane. This is where the needle is suspended. In that random plane, it is making 45 degrees. But the actual plane in which magnetic fields exist is this, because if you go like that, you get the magnetic poles over here. This is the different plane, and that plane is making an angle of 30 degrees. Fair enough. Now try to understand this over here. There are two components of Earth's field, horizontal and vertical. In this black random plane, there is a vertical component BV, and there is also a horizontal component BH. But this is not the true horizontal component. Think why? Because actually speaking, the Earth's magnetic field is in that direction, in this direction. So the magnetic field should be in that red plane. So truly speaking, the Earth's magnetic horizontal component is in this direction. This is just a component of that horizontal. Visualize this in that horizontal plane. Okay, in that horizontal plane, BH is this way. In this direction, you are just measuring the component of it, cos 30 component. So this is BH cos 30. Is that making sense to you? Is that making sense to you? Yep. Now, once you understand it, things will start making more sense. See, this 45 degrees can be written down like this by writing a trigonometric ratio. If I try to find out tan 45, which is opposite, which is BV, by adjacent, which is BH cos of 30, now I know what is BV by BH. BV by BH in general is your tan of true dip angle. True dip. This delta is your actual dip angle, BV by BH, in that magnetic plane. So just have to rearrange it. So this will become tan 45 is equal to tan of delta by cos of 30. So essentially tan delta will be, this is 1, cos 30 is root 3 by 2. So delta will be tan inverse of that. So tan inverse of root 3 by 2, which is option A. Perfect. Perfect. This is how it works. Is that okay? See, what has happened is, in that horizontal plane, try to understand this, there is Earth's horizontal component and there is vertical component. But the needle is not in that plane. The needle itself is in some other plane. It is in some other plane here. So this BH component is what I have chosen. So the component of BH will be BH cos 30. In that plane, this angle, which 45 degrees, will be this height, which is BV, by base, which is BH cos 30. That's it. Now I know BV by BH by definition is tan of the true dip angle. That's all. That's all. Okay. I hope this is clear. Fair enough. So that's the answer. Perfecto. Perfecto. Moving ahead to the next one. In the previous question, everything is fine, I think. Yeah. Oh. I think here there is a mistake. Thank you for pointing it out. Yeah, this should have been 10 to the power minus 5. Yes. Because this is 10 to the power minus 5. This is 10 to the power minus 5. This also should have been 10 to the power minus 5. Yep. Cool. Yes. Chalo, let's get moving to the next one. Oh, it's a time for break. I just give some rest for my throat. There are only 2 small chapters remaining. There are very interesting techniques, especially for AC, which I want to discuss with you. Shall we take a 10 minutes break? Yeah, shall we take a 10 minutes break? So Yoga Shimi, I'll tell you what. See, if you want to learn these chapters in detail, okay, still there is time. What you can do, we'll take a 10 minutes break, but before that, let me show you where and all you can find all these videos. So just go to playlist on our channel. Just go to playlist. When you go to playlist, right, over here, do you see Pathfinder? Pathfinder is 2022. That means 12th standard. Click on this. Click on this. You will see all my classes over here. Just click on Pathfinder Physics playlist. Just click on this. Just go down over here. Do you see this playlist? Right over here? Yeah, look at this. This is the entire Pathfinder playlist. So go down a little bit. Go down. You can see capacitors, magnetic sources and all of that. And go down a little bit. Magnetism, Earth's magnetism. You can watch the detailed classes over here. All my classes are over here. So I have finished EMI, AC. In fact, I have started light waves also. So you can watch it all over here. That's something which you can do. Not just that, let me also show you one more interesting thing. If you feel that these questions are very easy, sir, I think I should be doing JEE questions. Even if you are watching the video right now, even now you can join our JEE, final crash course, which is very, very crucial, last leg of your preparation. Even if you have not so much idea about JEE, have not prepared up to the mark, but you need that boost to push yourself, then you can go ahead for that. That's your JEE crash course 2022. Okay, so for all the 12th standard students, you can just go ahead, you can check, it's just for 9,000 rupees. It has test series, it has live classes, it has recorded classes, you know, it also will give you assignments, test series, report cards to compare your score with the previous year's toppers as well. So these are the things which you can explore. Meanwhile, that we take the break. So we'll take the break for 10 minutes. Okay, 10 minutes only. Let's return back. Okay, अच्छा 15 minutes. All right, chalo, we'll do that 15 minutes. No problems, guys. Let's do this break for 15 minutes. Okay, cool. Yes, you can join next week, Veera. Even if you join this week, let me tell you, you can choose to join next week. I mean, you can start attending from next week, and whatever you have missed, you will get recorded, or you can even join the batch which is starting next week. But the earlier you start, the better it is, because you will end it faster. You will push yourself and complete it. You will have a lot of time for revision. That's what I will tell you. Okay. Last 45 minutes class. Okay. So capacitance of a single conductor, Kirti Vasan, that is not there, bacha. What do you mean by single conductor? Acha, you mean like a sphere? So for a sphere, the capacitance is 4 pi epsilon naught r. You can think for a sphere, right? You know, the other plate or the other conductor is at infinity. So even an isolated sphere is a capacitor because it will store charge. Just that the second conductor is at infinity. So there is field right from the sphere till infinity, and it is storing the energy in the space around it. That's how you can think of it. Okay, that's how it is. Is there an offer like Term 2 plus JEE? Yes. So when you join the Pro subscription cyber piece, there is a link called as Pro subscription. I don't know whether you have seen that below. So there is a link over here. So Term 1 and 2. So there is crash course. You can see this. This is Term 1 and 2. So when you join this, you will get Term 1 and 2 preparation separate. But if you want just the Pro courses, then what you can do is, let's say you go to grade 12th over here. This includes your CBSE plus your crash course. All of these two things together. Okay, you can join this Pro course. So if you just want crash, then go for crash. If you just want CBSE, go for CBSE. That's all. Okay. Palimil, yes, you can join crash course after Term 1, but that will be little too late. I would suggest join as soon as possible. You can watch the recordings even later on. The second batch is starting this week, Monday. This coming Monday. Okay, this coming Monday it will start. Okay. If you have not yet started preparing, yes, crash course will help you, because last year there are so many students who joined the crash course even after, you know, not having done much. But once they got into the mood, they saw other students preparing, the teachers preparing, and also when they saw the assignments, then they got that moral boost and confidence. Then by second, third, fourth attempt, their scores started improving, and you know, finally they got into NITs, and some of them even got into IITs. So even if you have zero knowledge, you can still join the crash course. It's okay. Yeah, the second batch will start, like I said, this coming Monday. Okay, chalo. I'll take a break and I'll see you in some time. Good evening, good evening, good evening, my lovely warriors. Well, I hope you had your chota mota lunch and welcome back to the session, marathon session, and those of you joining in late, there's a formula revision and application class. We discuss the formulas at the start of the chapter and then I do questions based on that. Yesterday I conducted another marathon that was assertion, reason and case studies along with NCERT underline. In case you have missed it, do watch it. And if you're a JEE student and aspiring for cracking JEE 2022 and you feel this is easy, and I would suggest go ahead, join the test series with our classes and the last leg of preparation, which is the JEE crash course. So welcome back all my warriors. So yes, I did not eat my lunch, but I had some random junk, not junk exactly, but yes, I had some bananas. Yep, that's what I did. Yep. I was watching your Women in Science video. Oh, glad, Deepthi. I'm pretty sure you would have loved it and you would have enjoyed it. So Sanjit, I'll be having my lunch after this session is over. So let's get going. Hi Lalu, Aju, welcome aboard. Okay, so get your friends along. Make sure all your classmates, batchmates from your school, coaching, wherever they are on this session. The last leg of the preparation is going to start now. Okay, so time to begin. Okay. Okay, so yes, we have electromagnetic induction, right? Correct. So in EMI, what are the important formulas that we need to remember? We start with Faraday's law, of course. Let's write it down. So, and before Faraday's law, I think we should talk about magnetic flux. So if you have a coil or any area, and let's say there are magnetic field lines passing through it, so the magnetic flux phi b is given by field into area, the dot product. The dot is nothing but cos. This is the field and the area vector is always perpendicular. Remember, the area vector is always perpendicular to that coil. Now if the flux changes, what does it do? That change in flux produces or induces electricity, and when you say electricity, obviously there will be EMF, and if there is some resistance given, you can also find some current. Okay, so what is the formula for induced EMF? That is given by Faraday's law. So Faraday's law just says that the magnitude of that EMF is d phi by dt, rate of change of flux, how quickly that flux changes in that given time. And Lenz's law just tells one thing, that the direction of this current which is created inside the coil, the current which is induced, has only one job. This current produces induced field to oppose change in flux. Just to give you an example, imagine this is a loop. Okay, this is a loop, and imagine the field is coming towards you. This is the field. Let's say this B is increasing. It is increasing. Then in this particular loop there will be induced current. The question is, what is the direction of the induced current? Hanishma, induced means like I'm inducing knowledge in you. I'm not touching you. I'm not like, yeah, okay, I'm going to bring you close and yeah, stand under me. I'm going to give you blessings and I'm not going to transfer my energy. It's like wireless transfer. So I'm just inducing. So a magnetic field wirelessly creates electricity in a coil. How? When you change the flux. I hope that makes sense. Yeah. Now the minus sign is there when you remove the mod. I'll just come to that once again. So field is increasing here. If field is increasing here, by Lenz's law, to oppose it, you will create a field inside. So the induced field. So the induced field should be inside, right? If the induced field is inside, hold your thumb, right hand thumb inside the plane of the board. See how your fingers curl. See how it is moving. So this will be the direction of the induced current. That's all. Now When you are, most of the problems, when you solve it, you are not going to be worried about the sign so much. You are generally be talking about the magnitude. But if you remove the mod symbol, then what happens? This EMF will become minus d phi by dt. This minus is significant for Lenz's law. So for Lenz's law, it is just saying that it opposes the change in the flux. That's all. Otherwise, mod value mein there is no d phi by dt. There is no minus sign. Fair enough. Everybody clear to this point? Very good. Now, when you take a rod and you move it in the magnetic field, then also there is EMF created. This is called as motional EMF. Motional EMF, and the motional EMF formula is BLV. So this is the motional EMF formula. This is something again which you should remember. Very good. Okay. Now, Hari, that's what I told you. This is how you find out directions using Lenz's law. As simple as this. Hari, just see where the field is increasing. Field was increasing here. That's it. Opposite. How do you oppose? Keep a thumb opposite to it. See how your fingers curl. That's it. That's the direction of the induced current. I'll give you one more example. Imagine there is a coil. Imagine there is a magnet. This is north, this is south. Okay. For example, okay, this is the axis. Okay, something like this. Now, let's say this bar magnet is moving this way. If that is the direction of the motion of the magnet, it will create some field. How will the field look like? It will look something like this. Correct? This is how the magnetic field will look like. Now, if you talk about this field, as this bar magnet comes closer, more and more lines will cut through that. So, do you see the flux is increasing in this direction? More field lines will come over here. So, by Lenz's law, the opposing field, which is be induced, the opposing field which will be induced will be in this direction. Everybody agrees with that? It will be in this direction. So hold your thumb in that direction. See how your fingers curl. It will curl like this. So that's the direction of the induced current. Makes sense? Got it? Very good. Chalo. Moving ahead to the next part. There are only few things over here like inductors and all of that. So let me quickly tell you about it. So you have self-inductance and you have mutual inductance. So in self-inductance there is a coil, there is current. The own change in current causes opposition in the coil itself. So any changes in the current is opposed by the coil itself. In mutual inductance, you have a primary coil and it affects the secondary coil. So you have primary and you have the secondary. That's the only difference. So there is some flux associated over here. That flux is Li. In this case, the field produced by this will cut through the other coil. Okay, it will cut through the other coil. This flux is Mi. M is mutual inductance, L is self-inductance. If you differentiate this, you will get EMF, which is minus d phi by dt, which will be nothing but minus L di by dt. Same thing over here. If you want to find the EMF in the secondary coil, just differentiate the flux over there. So it will give you minus M di by dt. As simple as that. That's something you should keep in mind. And energy stored in an inductor. So every coil, every loop has its own inductance. So any loop can be considered like an inductor. And the best example is a solenoid. Solenoid is an inductor. So the self-inductance of a solenoid is given by L is equal to mu naught area of cross section into N square into L. What is this L? Length. This turns per unit length. A, area of cross section. Similarly, if you take one solenoid and inside that you put another solenoid, then we will be talking about mutual inductance. So the mutual inductance between two coaxial solenoids M is given by same formula, mu naught area of cross section of the smaller coil into, instead of N square you will put N1 N2 into the length of the solenoid. N1 into N2. That's it. Instead of N square, you'll put N1 into N2. Very easy to remember. And energy stored is half Li square. Keep this in mind. Fair enough? Cool? Great. Chalo, let's get moving to the next one. I hope you have noted this down. Okay, you can take a screenshot also if you want to. All right, there we go. The only thing which is now remaining is if you take a coil, okay, let's say this is the axis of the coil and you rotate it with angular speed, and let's say this is the magnetic field, then the EMF which is induced in the coil. Why is EMF induced? Think over here, this is the area vector. The angle between them will change. So the flux will change. Because the flux changes, electricity is created. This is going to produce an AC wave. So this is an AC generator. So the formula for that is something which is very important. Induced EMF is born, BA omega N sine omega T. Very important formula. AC generator. Okay. K root L1 L2, which formula? I'm not sure, honey, which one you are talking about. In terms of magnetism, honey. Okay, cool. Now, very good. Chalo, let's get moving then. I don't think anything else is left. Let's start with the questions, I believe. Let's start with the questions. Okay. The back EMF induced in a coil when a current changes from 1 ampere to 0 in 1 millisecond is 5 volts. The self-inductance of the coil is how much? That's the question. How much is the self-inductance of the coil? Figure this out. Now the back EMF, that means the induced EMF is given and the current changes in this self-inductance. Which is the formula? I think you have to use minus L di by dt. Just use this. The EMF is 5 volts minus L, change in the current from 1 to 0. So delta I will be minus 1. This will be minus 1 in how much time? In a time of 1 millisecond. So 10 to the power minus 3 seconds. Minus minus will cancel. So L will be 5 into 10 to the power minus 3 Henry. Is that the answer? Okay. Very good. Very good. Let's get moving to the next one. Perfect. Somebody was asking what is the difference between the behavior of an inductor in AC and DC. So an inductor in DC, okay, is like just a wire, whereas in AC circuits you will see an inductor will behave like a resistance. That resistance is called as inductive reactance. That is called as inductive reactance. So for AC, inductor provides some resistance. For DC, it is like a wire. That's something which you should know. Next, the magnetic flux linked with a coil is given by this equation. The induced EMF in the coil in the third second will be how much? Okay, very interesting. Just direct formula. Okay, direct. Let's do this. So EMF will be minus d phi by dt. The question is just the magnitude, I believe, but still. So minus d by dt of 5t square plus 2t plus 3, which is minus derivative of this will be 10t plus 2. So EMF at 3 seconds will be minus 10 into 3 plus 2, which is minus 32 volts. So I think we have just to find the magnitude of it. So the modulus of that will be just 32. Correct? So that's 32 units. Perfecto. Perfectos. So, this problem also tells us that, there are multiple ways of changing or creating EMF. See, flux is B A cos theta. Either you change B, or you change area, or you change theta. In this question, flux was changing because B was changing. Area can change if you change the shape and size. And this can change if you change the orientation. So any of these three things can cause flux change. Moving on to the next one. The current decays from 5 to 2 amperes in this much second of a coil. The EMF of the coil is this much. What is the mutual inductance of the coil? Very interesting. What's the mutual inductance? The current has changed. So I think because EMF is given, I will just use minus M delta I by delta T. The EMF is given to be 30. The mutual inductance, I don't know. Change in the current from 5 to 2. Final minus initial by the time 0.01. So this will become minus 3 and take this over there. So it will become 30 into 0.01 into m. Okay, and this will be also become minus 3, I believe. Yes, minus minus becomes plus. So m will become how much? 0.1 Henry. Just check this out. If it is correct, yes, option A should be correct. No, Naidu, it is not B. It should be option A. Yep, it is option A. Very good. Moving on to the next question coming up on your screen. There is a coil of inductance 40 Henry. It is connected in series. So the question is, what is the time constant if it is connected to the battery? What is the formula for time constant? Yesterday also I discussed this, and today also it's coming. Time constant is L by R. Time constant is L by R. If you know this, that's it, your job is done. L is 40, R is 8, this is just 5. So answer is 5 seconds. Done, done are done. Time constant is L by R. So keep this in mind. For LR circuits, it is L by R. For RC circuits, it is RC. Just RC. That's it. Done, done are done. Very good. 5 seconds. Next question coming up on your screen. A coil having area A is placed in a field which changes from B to 4B. In time t, EMF will be how much? Very nice. So B has changed. So I think the induced EMF again using Faraday's law again. So let's use Faraday's law. So according to Faraday's law, EMF will be del phi by del t. Change in the flux will be final flux minus initial flux. So I think I can write it like this. Final flux, okay, so final flux minus initial flux upon the time taken. Final will be 4B naught into the area which is A naught minus initial flux will be B naught. There is minus sign also. If you want, you can put this right over here. So B naught into A naught, and this whole thing divided by time. How much is the time? T. So 4 minus 1, that's 3, and so you will get this as minus 3 B naught A naught divided by T. Is it there? Yes. So that's the magnitude of it. So you take the modulus. Just take the modulus. Got it? That's it. Just take the modulus. Don't worry about the minus sign. What have I told you about the minus sign? It is not so important for most of the problems. The minus sign just signifies the direction. So most of the times they are going to ask you magnitude. Next question. There is a coil which has so many turns. The question is, if it is rotated by 180, what is the value of induced EMF? Okay. Thank you, Samriddhi, so much. All right, let's get going. Yes, Suhani, obviously. Yesterday also I was teaching till almost 4:30, but today we'll be ending within next 15-20 minutes, not more than that. The coil has these many turns, this much is the area. Okay, so what is the induced EMF? So this is my logic. If the coil was facing like this and you turn it, and then the area vector goes like this, okay, and the magnetic field was here, so obviously the flux has changed. How, you might ask? See, the initial flux, if it is BA cos 0, the final flux is BA cos 180. This is BA because cos 0 is 1. 180's cos is minus 1. So minus BA. So hence, when I try to calculate the EMF which is induced, which is del phi by del t, what I will just say, final minus initial. Oh, by the way, there is minus sign here. So minus final minus initial, which is again BA, but divided by time. What is the time? Okay, I'll just put it over here. And there is one more catch. There are 2000 turns. So I'll have to multiply this n times. In fact, over here also I need to multiply it n times, because each turn will add to the flux. So just multiply it by n. So minus BA is minus 2BA. So minus minus becomes plus. So 2BAN divided by 2. Now just substitute, by T. So now just substitute the value. So 2 into field. What is the field? It is 0.3. What is the area? It is 70 into 10 to the power minus 4 into turns is 2000, which is 2 into 10 to the power 3. The whole thing divided by the time, 0.1 second. That's it. Just do the math and you'll get it. So 2 2s are 4, 7 3s are 21, 21 4s are 84. So it should be either A or B. Just check this out. Is it A or B? One of them. It's coming out to be B. Well, is it? Very good. Let's see if you guys are correct. Excellent. It is correct. Very good. Okay. Very good. Very good. Let's get moving to the next one. Wow, this is an interesting one. Many students will make a mistake. A jet plane is traveling west at a speed of this much. Voltage difference between the two ends is this. Having a wingspan of 20 meters. If the Earth's field is given and the dip angle is given, is how much? Okay, I'll tell you how to solve this. First of all, just imagine the plane. Okay, imagine this is the plane. It's going like this. Okay, this is the west direction. This is 20 meters. This whole thing is 20 meters. Now, the Earth will have magnetic field in the north-south direction, but I won't need the total magnetic field. What I need is only this component, because in that BLV, that B is this inside magnetic field. So to find out EMF, I need BLV. This B is this inside field. Now think carefully. You are looking at it from the top. There will be two components, right? There will be one horizontal component, BH, and there will be one vertical component. So this B, which I need, is BV. Is that understood? So I need BV over there. So how much will be BV? So you can just visualize it by a simple triangle. This is B, this is theta, this is BH, this is BV. So BV will be B sine theta. So hence you can see over here, this is B sine theta into L into V. Now just solve the problem. Field is 5 into 10 to the power minus 4 sine of 30 degrees into length, how much? 20, and velocity, which is 1600, but multiplied by 5 by 18. Now you will get the answer. Got it? Got it? Very good. So the whole idea is that here many students forget that the dip angle is there and they just use this field, and then they don't know which component to choose. So whenever you have a rod, always choose the perpendicular component to the length. That is the field which will come. Yep, that's how it is. How cross? What do you mean by which cross? Okay, how BV is only taken? See Adit, that's what I just said. So whenever you have motional EMF problems, you would have seen this B is there. Correct? What is this field? This is the field which is perpendicular to the length and velocity, right? Now the plane is going like this. This is the rod. This is the rod. Which is this component? You're looking at it from the top. The raindrop will fall like this. This is down. This is down. This, remember, is north. This is south. So this is the ground plane. So that is horizontal, that is vertical. So that's why I will take BV, which is the vertical component. Understood, Adit and others? And why 5 by 18? This is your kilometers per hour to meters per second. So how do you convert kilometers per hour into meters per second? You have done this conversion. 5 by 18 multiplied by 5 by 18, it will convert it into meters per second. Understood now? Perfect. Let's go ahead. Chalo. Thank you. Very good. Wow. Look at this. We have reached alternating current. Crazy. Let's do the questions. But before that, let's do the formulas. Now I'm going to tell you some interesting things over here. So pay attention. First of all, see, if you have AC circuit, what is this called? This is called max or peak value. You have something called as the RMS. Now the RMS is always the peak value by root 2. The meaning of RMS is that when you pass AC current through a resistor, it will develop some heat. What will it create? It will create some heat. This is AC. Now, when you want to find out how much heat is generated, okay, understanding AC might be difficult because the voltage is continuously changing. Current is also fluctuating. So, if I tell you one constant current, DC current, which is passed through the resistor and it develops the same heat, then you will get the feel of it. Acha, 5 amperes current is going. Then that current is called as the RMS current. So RMS current is the quantity of current which produces the same heat as that of the AC circuit. So it gives you a comparison. That's all. Okay, that's all. Cool. Now, apart from that, you should remember the transformer ka formula, AC transformer. I'll then go to the phasor diagrams and all of that. Hold on, I'm not skipping it. The transformer has one of these three roles: either to increase the voltage or to decrease the voltage, or sometimes it is also used to keep the voltage same, but just to create some kind of isolation. You want two circuits to be disconnected from each other. So that time also you can use it. So if you take primary turns as N1, this is called as the primary, this is secondary, you will see when you pass AC current over here, this AC current will create a magnetic field around it, definitely, and because the current changes, the B also changes, and that creates induced electricity in the secondary. So you will get secondary voltage. So if this is I1, this is V1, this is I2, this is V2, then remember simple formula N1 by N2, which is also called as the turns ratio. Turns ratio is V1 by V2, but current wise it is I2 by I1, something which you should know. It's inverse for current. Okay, keep this in mind. Very good, excellent. Now, apart from this, when we talk about LCR circuits, this is L, we'll solve this together. This is R, and you connect it to an AC source. Let's say this AC source is E. Let's say there is some current flowing through this. Let's say I call it I. Let's say this I is I naught sine omega t. This I naught sine omega t mein I naught is the maximum, omega is the frequency, angular frequency. Now this is inductor, capacitor, resistor. Across the inductor you will have some voltage. This is VL. Across capacitor, VC. Across resistor, VR. When you add all of them, you will get the total voltage E. When you add all of them. But you cannot just directly add them. This is one common mistake. So let me tell you, VR plus VC plus VL is not equal to E. Yes, it is not equal to E. The problem is the voltages are not in the same phase. So that makes, or that basically needs, to take the help of something called as the phasor diagram. Phasor diagram tells you when there are 2-3 more sinusoidal quantities which are varying with respect to each other, it helps you analyze those quantities in a much easier fashion, very easy fashion, just like what you have studied in waves. So for example, I tell you there is a phasor of current. Let's say this is the phasor of current, I naught. That means if this arrow mark rotates, as it rotates, the height of it represents the instantaneous value. The height of it. So as it goes up, the instantaneous value increases. As it goes here, it decreases. So as this arrow mark rotates, the instantaneous values keep on fluctuating. So that phasor helps us understand those currents and voltages. Now, what happens is, in case of an AC circuit, the voltage across the resistor is in the same phase. So VR is like this, meaning if this is the current, then voltage is also in the same phase. There is no shift between them. But for inductor and capacitor, there is a change. In fact, I told you, for inductor, it is always on the top. And the best way to remember is love is above all. Love is above all. That means L, love. Yes, love is above all. So VL is on the top and VC, C is below. C is below. That's it. So voltage is ahead of current. Okay, by the way, if you are wondering which one is ahead or which one is behind, this is how it rotates. It all goes like that. So VL is ahead of current. Capacitor's voltage is behind the current by 90 degrees. Now it's just a matter of treating them like vectors. Yes. So when you add them like vectors, VR vector plus VC vector plus VL vector, then it is E vector. That's how you should understand. So if I tell you add these three forces, first you will get rid of these two forces. So what will you get? You will get this one as VL minus VC or VC minus VL, whichever is more. This force or this vector will come over here, and then you will find the resultant of these two. So how will the resultant of these two look like? The resultant of these two will be here. So this is your final vector, right? So this is how your final EMF is going to look like. So you might be wondering, sir, what is the magnitude of this EMF? Well, you can see it directly from here. It's Pythagoras. So strictly speaking, what is E? E is nothing but root of base square plus height square. So VR square plus VL minus VC whole square. As simple as that. Got it? Is it understood? It's so easy to remember. Now, once you're done with this, remember there is also some angle between them, that is the phase difference. Angle between the current and the voltage, what is it called? It is called the phase difference between the total voltage and current. There are different ways in which you can write it. Like for example, you can say cos phi is VR by E. VR by E is cos phi. You can also say tan phi. Tan phi is, see, look at this. This is the same angle. VL minus VC by VR. One and the same thing. Yep. Now, once you understand the voltages, understand the resistances also can be written down. Trust me on this. See, one thing you should see, that current is same across all of them, voltages are different. Why is current same? Because it is in series. So if somebody asks you what is the value of VR, you should quickly jump and tell VR will be I into R. Ohm's law, V is IR. If somebody asks you what is VC, VC is I into XC. VL will be I into XL. What is this X? Equivalent of resistance for capacitor and inductor. So XC is nothing but 1 by omega C. XC is 1 by omega into C, and XL, what is XL? It is just omega L. That's something which you should keep in mind. Inductance into frequency, angular, gives you the equivalent resistance of an inductor. Reciprocal of omega into C gives you equivalent resistance of a capacitor. So once you understand this, you can even draw a triangle for resistances. Look at this. You can draw resistance horizontally because VR is here. XL, you can draw it over here, and XC, you can draw it below. That's it. Now again, just like you did it over here, you take care of these two. So you will be just left with, I think, XL minus XC. If you subtract these two, the resultant of this and this vector, you will get the total effective resistance. That resistance is called as Z, which is impedance. That is called as impedance, nothing else. And this is your, again, the same angle. Now you can see, you can also write cos phi as, cos phi as base by hypotenuse. You can write tan phi as opposite by base, which is XL minus XC by R. So one and the same thing. If you know this vectors, you also know these vectors. Okay. Last thing. Just like I told you that voltages don't add, but they add like vectors. Same way, resistances don't add. They add like vectors again. Meaning, Z is not equal to R plus XL plus XC. Wrong. This is not true. In fact, Z is R vector plus XL vector plus XC vector. So strictly speaking, Z is root of root of this square plus this square. So it will be r square plus xl minus xc whole square. So do you see that if you treat these like vectors, it actually becomes easy. The meaning of impedance is the collective effective resistance of resistors and inductors together and capacitors together, because inductor and capacitor also opposes AC, so their collective resistance is called as resistance. But then why don't you use the word resistance? Because only resistor loses energy, inductor and capacitor do not lose energy. That's the main difference between them. So we have given them different terms like reactance. Got it? Very good. Now, yeah, so leading and lagging. So you can see over here, everything is clear. EMF leads the current in this case. Capacitor's voltage lags behind the current. It is behind because voltage across the capacitor is behind the current. Current goes first, then comes voltage of capacitor. In case of inductor, voltage comes first, current goes later on. But in case of resistor, voltage and current are in sync, in phase. That's how it works. Got it? Fair enough. If XC is much larger than XL, then the entire Z and entire E will almost be here. It will almost be here. Cool. Now one last thing over here, the power. A lot of you need the power formula. So the power in a AC circuit is I squared R, or you can also use VI cos phi. Very important. This V is VRMS, this I is IRMS, and cos phi, that is also very important. This cos phi is called as the power factor. Power factor. Keep this in mind. Very good. Chalo. Let's start doing some questions then. I believe it's good time to start doing some questions. Okay. Hari, see, simple. Just look at this diagram. It's very obvious. If I tell you Laddu, Champu and Raidu. Okay, this is Raidu, this is Laddu, this is Champu. All of them are going in circle like this. They are going in circle like this. Who comes first? If you wait here, Laddu comes first, resistor Raidu comes next, Chandu comes next. That's it. So look at it this way. Voltage is ahead of current. This voltage is behind of current. This voltage is with the current. This voltage is ahead of current. That's all. Very good. Now that we have spoken about all this, the last few things over here. See, again, when you have LCR circuits, this is your source. If somehow the source frequency is omega, you adjust the source frequency and you check what's the current in the circuit. Check what's the current in the circuit. Then this current graph looks somewhat like this. It becomes maximum somewhere. So it becomes max somewhere. When it becomes max, that is called as resonance. Meaning, not all frequencies are favorable or acceptable to this circuit. Some frequencies, they will resist more. But there is one particular frequency, they will accept it. That most accepted frequency, that's when the current is maximum. And when resonance occurs, what happens is the XL value and XC value will be equal. So the total impedance is just the resistance. Z is just R. Basically, what happens is the voltage and the current are in the same phase. The total EMF of the circuit and the current are in the same phase. Phi is 0. That's what happens during resonance. And this frequency is nothing but called as the natural frequency, and very simple formula, root LC. 1 by root LC is the natural frequency of that circuit. When it matches, then the impedance is just resistance. Power factor is 1 because angle is 0. XL and XC both cancel out each other. And why is it called as the natural frequency? Because if you take only inductor and capacitor and if you charge it, you will see the charge will go back and forth at exactly this frequency, which is the natural frequency of oscillation of the charges and the current in a LC circuit. So what happens is that if you force this circuit with an external source at the same frequency, it will vibrate, it will oscillate, it will take that current in a maximum value, and that's when it resonates. I hope this is clear. Cool. Let's solve some questions, and there are some interesting parameters over here like quality factor and bandwidth. So bandwidth is this over here. So bandwidth is over here. This is bandwidth. Bandwidth is the range of currents for which at least half the energy is transmitted. So all those frequencies for which at least half the energy goes in the circuit, is that range of frequencies over here is the bandwidth. And yep, the bandwidth formula is nothing but R by L. That's something which you should remember. Okay, very, very important. Cool. And yes, you should also remember the quality factor formula. So quality factor is natural frequency by that bandwidth. So if you take natural frequency and divide it with the bandwidth over here, so bandwidth delta W, okay, that will give you the quality factor. That's something which you can remember. Okay, now in your NCERT, they have given the bandwidth as 2 delta omega. Again, I don't know why they fancy this 2 so much, but understand, if you remember what is bandwidth, you don't have to remember whether it was 2, whether it was half or something else. What they have done, I'll tell you, in NCERT, this is like this. This is the natural frequency maximum current. These are the 2 points where you get at least half power. What they have done, this they have taken delta omega, this they have taken delta omega, and then collectively bandwidth will be 2 del omega. Why do you want to do that? Just say bandwidth is del omega, yaar, simple. Why do you want to write half separate? It's easy, okay? So don't have to remember it 2 times and all that. Okay, as simple as that. Cool, let's do some questions based on AC now. Here is the first one. The equation of a AC voltage is this much. What is the average and the frequency? So Sriji, I'll tell you what is the gist about LC oscillation. Simple way to remember. You remember spring and mass, just remember that. That's it. Then you'll also remember L and C oscillation. This is L, this is C. Instead of spring, you put 1 by C. Instead of mass, you put inductor. You get everything as the same thing. Time period is 2 pi under root M by K. Here it is time period is 2 pi under root. Instead of mass, you put L. Instead of K, you put 1 by C, which is 2 pi under root of LC. So here the position changes, right? The position changes. Here the charge changes. And when position changes, there is velocity. Here rate of flow of charge, you have current. So wherever you find X, put Q. Wherever you find velocity, put current. They are all very similar. If you understand that, that's it. You don't have to remember it specially. So a charge capacitor will get discharged. It will pass on the current like this. Once it is discharged, again it will get charged. Again it will discharge. Again it will get charged. That's what keeps on happening. Here the mass keeps on going. The X keeps on changing up and down. That's the only simple way of remembering it. Cool? Chalo. Let's see this question. Many of you have said option C is correct, but I have a feeling that most of you are wrong. Okay, if angular frequency is applied on the inductance, instantaneous power will be the angular. I'm not sure what you're saying. Can you be little bit more specific? Well, meanwhile, the answer for this is not C. It is actually A. You please read the question carefully. See what does it say? Average value. This is AC voltage. So it goes up, goes down, goes up, goes down. What is the average? The average is this. This is the average. And the average will be 0. What are you guys doing? And this 100 pi is omega. Omega is 2 pi f. So f will be 100 pi by 2 pi, which is 50. So that's why this 50 is there. Be careful. Be careful. Average is 0. This 70.7, what you guys are saying, is actually the RMS value, 100 by root 2. Be careful. Got it? Understood? Yes? Let's go ahead to the next one. The next one is output of a step-down transformer is 24 when connected to a bulb of 12 watts. What is the value of the peak current? So essentially you have taken a bulb, okay, of 12 watts and you have to pass some current. The voltage is 24 volts. What's the peak current? Now just simply use power is V into I. Power is V into I. Now when you do this, power is 12, voltage is 24 into current will be half, which is basically 0.5. Now most of you will be looking at the options and you'll be like, sir, the answer is not there. So read the question carefully. This is peak. The question is asking peak current. This current which you have found out is just RMS value. Yes, when nothing is mentioned, everything is RMS. Even this is just RMS value. So once you know RMS, you can find the peak, because peak by root 2 is RMS. So basically the peak value will be root 2 by 2, which is 1 by root 2. Hence option A will be correct. Yeah, not B, it is A. Be careful, you made a calculation mistake if you got it as B. Understood? So when nothing is mentioned, it is always RMS. What is the relationship between IRMS and I average? See, average value of any AC circuit, right, is always 0. Whatever is positive is negative, whatever is positive is negative. Understand? So it is always going to be 0. Be careful. Okay? So RMS will be maximum by root 2. Average will be always 0 if positive and negatives are equal. Moving ahead. R is given, L is given, C is given, omega is given. Find the impedance of the circuit. Find the impedance of the circuit. Let's see how many of you can do this. Okay, so what do we have? Okay, so I think to find impedance we need R. We also need XL minus XC. Only then I can find impedance. How do I find XL and XC? Well, XL I just gave you. It is omega L. Omega is 10 to the power 3. L is 0.9. That means it is 900. XC is nothing but 1 by omega C, which means it is 1 by 10 to the power 3 into capacitance. How much is it? 2 microfarad. So 2 into 10 to the power minus 6. So this will be how much? 1000 divided by 2, which is 500. Okay, fair enough. Now look at the triangle. XL minus XC. XL minus XC will be nothing but 900 minus 500, which is 400. Resistance is 300. So just mark this as 300. Question says, what is the impedance? Pythagoras, that's it. This is 400, this is 300. How much will Z be? Obviously root of 400 square plus 300 square, which is the root of 500 square, which is 500 ohms. That's it. So where is it? Option C. Done. Very good. How omega is 10 to the power 3? Because 1000, my dear warriors, is 10 to the power 3. That's why omega is 10 to the power 3. Okay, CB? Yeah, 3 zeros. You can count 3 zeros. 1, 2, 3. So that's why 10 to the power 3. Moving ahead to the next one. Okay. In a series LCR circuit, R is this much, impedance is this much, then the phase difference between the current and the voltage is how much? Let's see how to do it. Is it okay to, if you study all the formulas, obviously BN gamers, you have to study all the formulas. How else will you do it? That's why I'm conducting this session. Why do you think I'm wasting my time here? No, right? So you have to learn all the formulas and also learn how to apply it. That's what we are doing here. So again, construct our standard triangle. This is R, this is XL minus XC, this is Z, this is phi. If you remember, Z was always in the direction of EMF. This was current. This is how it was. I think you can make use of some trigonometric ratio, most likely cos of phi. Cos phi will be R by Z. So R is how much? 10. Z is 20. So it is half. So whose cos is half. Obviously it is 60. Where is it? 60. Yep. Cos 60. Yep. Option A. There you go. Perfecto. Perfecto. Excellent. Moving ahead to the next question. In a step-up transformer, the ratio of turns primary to secondary is 1:10. Primary voltage is 230. The load current is 2. Then the current in the primary is. So if you are getting confused, always draw a diagram. It helps a lot. So this is our transformer. The ratio is 1:10. The current in the primary is 2 amperes. The question is, what is the current in the secondary? I think I just told you that the turns ratio is inverse to the current. So it will be primary by secondary will be secondary by primary. Okay, so secondary I don't know, primary is 2, so 1/10. Okay, that's what is asked. Oops, sorry. The current in the primary is asked. I'm so sorry, I made a mistake over here. So sorry. The current in the primary was asked. Current in the primary was asked. The current in the load, that means this is 2 amperes. Yeah. Now let's do this again. Turns ratio, primary by secondary is secondary by primary. So secondary is 2, primary is I don't know, this is 1/10. So IP is 2 into 10, which is 20 amperes. So 20 amperes is right over here. That's it. Very good. Yes. So primary current is what is asked. The load current. Load also means secondary. Okay. This is where it is generation side. This is the load side. It is generated, it is converted. So what is the use of this? There is no use of this. It's just waste. Yeah. That's all. Cool. Moving ahead to the next one. Resonant frequency is given, is asked, and the L values, C values and R values are given. Come on. Let's see how many of you can do this question really quick. Come on, my warriors, figure this out. What do you think is the resonant frequency of this circuit? First of all, what's the formula for resonant frequency? This is all in hertz, right? So remember, time period was nothing but 2 pi under root m by k. Instead of mass you put L, instead of k you put 1 by c. So frequency will be 1 by 2 pi root of LC. Oh, so just substitute everything. So 2 pi root of L. L is 2, C is 32 into 10 to the power minus 6 because it is micro. What about resistor? It is not needed. It's just given, time pass, ignore it. 32 into 2, 64. Root of 64, what is it? Root of 64 is 8. Root of 10 to the power minus 6 is 10 to the power minus 3. Correct? And oops, I think I had to put pi over here. So 2 pi. Yeah. So that's it. So take 10 to the power 3 there. So 10 to the power 3 divided by 16 pi. Yep. So calculate this. How much is it coming out to be approximately? Let's calculate this. How much is it coming out? Yeah. Not 1 by root LC. The 2 pi is important. Understand? Frequency means F. Angular frequency means omega. Frequency is 1 by 2 pi root LC. Omega is 1 by root LC. So see what has been asked and check the units also. It is hertz. So be careful. A for sure. Let's figure out whether you guys are correct. Yes, you guys are correct. Wow. What an amazing session it has been. I congratulate you to complete this session because you have completed this successfully. You have been attentive, you have been solving, you have been very involved in this session. Now the next step is not just, your board examination. The next step is, your JEE examination, your KVPY examination, your JEE advanced examination, your BITSAT examination. And you cannot start preparing for JEE in the last month. You have to start it now. The batches are starting this week and even the next week. In fact, there is a batch which has just started the last week. You can still watch the recordings right on your mobile phone or even on your laptop. That's your JEE crash course. Yep. All of you are asking, sir, what is this JEE crash course? This is a full syllabus revision. for JEE 2022 aspirants with 90 classes, which will be also given to you as recordings. Also, there will be 10 full syllabus tests, 10 part syllabus tests. You can compare your ranks and your percentages with the toppers, which is very important because you cannot just keep on giving tests and then there is no use. You don't know where you stand. Also, you get access to the Doubt app. Not just that, you also will get the notes, you will get assignments after every class. You have such a big question bank to solve that you will have so much practice and before your JEE mains you will be very, very well prepared. Who should join the crash course? All those students who are not happy or not so satisfied with their current coaching, or those students who have not yet started complete preparation for the JEE exam, or those students who are prepared but feel that they need some additional practice material and additional test series. So all those students should join this, and guess what, the price is just not 20,000, not 10,000, it is 9,000 rupees on a limited time offer. That offer can change anytime. Don't ask me later on, sir, the price became 10,000 or 20,000. So what you need to do is just go down. Here you can see JEE crash course. Just click on this. There you get JEE crash course. Just click on this. You have two versions, light and classic. Don't choose light because even when you choose classic, the price is same. What is the advantage? You will get doubt solving on the mobile app. That's the advantage. So you can click on this and say buy complete course, enter your phone or email ID. That's it. So make sure that you use this coupon code, because if you use this coupon code, then only you will be able to get my support if anything goes wrong or if you are facing any issues. So make sure you use that. Alright. There is another option for those of you who want to continue your preparation for CBSE only. No problem. Then you have CBSE Term 1 and 2 preparation made for you. Click on this link, that will help you. If you want more courses, like for example KVPY crash course, you can see KVPY crash course is available just for 1,800 rupees. Hardly 30-20 days are there for your KVPY examination, 1 month. So watch these classes, get your assignments and do your analysis. This is for KVPY SX examination. 1,800, it's pretty cheap. So try all these things out. It's up to you where you want to enroll yourself or where you want to invest your time. Yep. So first of all, thank you for attending, and thank you for all the love and likes that you have given on the bottom. Thank you so much. Thank you so much, Iben. Take care. Have a great time. Make sure you have subscribed. Make sure you recommend the channel, and make sure you can also follow me over here on Instagram. Now tomorrow I'm going to meet you at 11 o'clock, but it's not going to be a big session. It's just problem. Are you ready? Are you going to be there? Yeah. So I'm hoping to see all of you tomorrow. Prepare well, revise now. Tomorrow I will leave you before 1 or 1:30. Okay, from 11 we'll start till 1:30 we'll wind up the session. Yeah. So after this session, I want you to go through the sheets and solve more problems from exemplar, from NCERT back exercise, sample papers, MTG or OSWAL, or even the PDFs which I have uploaded on the Telegram channels, and also go through the formulas today. Tomorrow it's just problem solving. Don't sit and remember formulas tomorrow. Tomorrow is a day only for problems. That's how I have planned these sessions. Okay. Okay, chalo. I'll eat my lunch now. I'm also very tired. I don't know whether my energy looks down or up, but I have tried to do my best. So please make sure you shower your love out there. It means a lot for me. Okay. Chalo. Signing off. Take care. Hasta la vista. This was Captain Shreyas.